Hello and welcome to this episode, and in this episode we want to discuss about the associativity rule with rational operators. That means that if we have multiple rational operators in just one expression, so how do we resolve that expression, or how do we evaluate that expression? So let me write down an example for you in here. Maybe I have this rational expression that 3 is greater than 4 is greater than 5 is less than 0. So if we have an expression like this, and we have, you can see that many rational operators in this statement, how we would be able to evaluate this statement. So the way we are going to evaluate this expression is going to be from left to right, the same way that we did with arithmetic expressions. So we had addition, subtraction, multiplication, and all of these arithmetic expressions, and we would evaluate them from left to right. This is the same way we are going to evaluate this expression as well. So now let's go and evaluate this expression. This part is 3 greater than 4. No, that means that the result of this part is going to be 0 or false, because 3 is not greater than 4. So we have a false in here. So we have a false, and then 5, and then less than 0, and the rest of the expression. Now once again, we will move from left to right. Is 0 greater than 5? Still, 0 is not greater than 5. That is false as well, and false will result into 0. So the evaluation of this part is equal to 0. 0 is less than 0. And once again, is 0 less than 0? No, 0 is equal to 0. So this is false, and once again, the evaluation of this part will result into 0. Let's go and evaluate, maybe make a little bit of difference for this expression in here, because I want to show you what happens if the part of an expression is true. So if we have something like this, let's go and clean this part. So now if we have this change, we have 3 less than 4, and then the rest of the expression. Now this part of expression is going to result into 1. So 1 greater than 5 less than 0. Once again, we will continue from left to right. 1 is greater than 5. No, that is incorrect. That is false. 0 less than 0. And obviously 0 is not less than 0. Then once again, this expression is going to result into a false result, or 0. So remember that if an expression results to true, or part of the expression results to true, we would use 1 for that part of the for the result of that part of expression. So 1 means true, and always 0 means false. Now let's go to my laptop and see that if we get the same result if we put this expression in a printf statement. So here we are on my laptop. We need a printf statement, and we want to print the integer result of an expression. That expression is going to be 3 less than 4 greater than 5 and less than 0. And this is the expression that we have that we want to evaluate. This is the second part of the example on the board that I evaluated, and it resulted in 0 as well. So we will be able to get a result of 0 using the printf statement as well. Let's go and run this program, and you can see that the result of this is equal to 0. Maybe if we want it to give a result of 1, we can change this last part to equal, and then it will be able to give us a value of 1. You can see that we got a value of 1 or true. How it became true is that 3 is less than 4. This evaluates into 1. 1 is greater than 5. This evaluates to 0. Finally, this whole part results to 0. 0 is equal to 0. That means it's true. And finally, we got the value of 1 or true. That's it for this episode. I see you in the coming episodes.